Solutions are mixtures, meaning that the solute and the solvent can be mixed in any proportions. The relative amount of solute in a solution is measured by the concentration of the solution. A more concentrated solution contains more solute than a less concentrated solution of the same amount. A common way to express concentration is molarity, which is the number of moles of solute present in a liter of solution. Hence, the formula for molarity is the ratio between the moles of solute and the volume of solution measured in liters. To prepare a solution with a specified concentration, the solute is weighed on an analytical balance and transferred to a volumetric flask. Then, a portion of the solvent is added, and the mixture is swirled to completely dissolve the solute. Once the solute dissolves, enough solvent is added to bring the liquid level to the mark on the flask measured from the bottom of the meniscus. A couple of conversions are needed to be done before calculating molarity. First, from the mass data, the number of moles of solute is calculated. The conversion factor is the molar mass of cobalt-2 chloride dihydrate. Then, volume in milliliters is converted to liters because the unit of volume in the molarity expression is liters. The use of the volumetric flask determines the volume to 2 decimal places. Therefore, the volume measurement has 5 significant figures. Finally, molarity is calculated by dividing the number of moles of solute by the volume of the solution to give 0.08000 moles per liter. It is important to note that the volume of the solution is not equal to the volume of the solvent used. This is because the solute itself takes up space in the solution. For example, to make a 250 milliliter solution, less than 250 milliliters of solvent is needed. Since molarity is defined per the volume of the solution, we are interested only in the final volume of the solution, not how much solvent was added. Calculating molarity based on the volume of solvent added would be an incorrect way to calculate molarity. In this example, a solution of potassium dichromate is prepared by dissolving 1.52 grams of it in a 50 milliliter volumetric flask. The solution is prepared by first dissolving the solute in minimal water, then adding more water to bring the solution up to the mark on the flask. To calculate the molarity of the solution, we first need to calculate the number of moles from the mass of the solute. We use the given molar mass and find the number of moles. Since the volume is given in milliliters, we convert the units to liters. In the last step, molarity is calculated by dividing the number of moles of solute by the volume of the solution to give us the concentration as 0.103 molar or moles per liter. Let's see the use of the molarity expression to calculate the other two variables in the equation, number of moles and volume. In this question, the moles of glucose in a 250 milliliter of a 0.5 molar solution is asked. There are two ways to solve this question, one of which is by using the molarity formula. From the formula, we get that the number of moles is equal to the product of molarity and volume. Multiplying molarity, 0.5 moles per liter, by the volume in liters gives 0.125 moles of glucose. When writing this equation, the molarity unit is written expanded as moles per liter to be able to cancel the liter units and obtain the answer in the unit of moles. In the alternate solution, molarity is used as a conversion factor between moles and volume. The given molarity, 0.5 moles per liter can be interpreted as a unit equation, such that 0.5 moles is equal to 1 liter. Then, starting with volume in liters and using the unit equation to set up the conversion factor, the number of moles of glucose is calculated. In questions like this, it is alright to use either method. However, in questions that require multi-step conversions, it would be necessary to use molarity as a conversion factor. Therefore, it is recommended that you are comfortable with the use of either method. In this example, the volume of a solution of hydrochloric acid is asked given the concentration and the number of moles of solute in it. To find volume, the molarity formula is rearranged to solve for volume, which gives number of moles divided by molarity. Dividing the given number of moles by the given concentration gives the volume of the solution in liters. Once again, the units of molarity is written as moles per liter in order to verify the cancellation of units. In the alternate dimensional analysis method, the number of moles is converted to volume using molarity as a conversion factor. Starting with the number of moles, the unit moles is placed in the denominator and the unit liters is placed in the numerator. The given concentration tells that 1 liter of the solution contains 0.1231 moles of hydrochloric acid. After cancelling the units, the volume is calculated. In this example, the mass of the solute in a given solution is asked. Since mass can be calculated from number of moles, the first step is to calculate the number of moles of the solute. This can be done using molarity as a conversion factor or by using the formula. But first, the given volume in milliliters is converted to liters. Then molarity is used as a conversion factor to calculate the number of moles. And finally, mass is calculated by using the molar mass of the solute as a conversion factor.